Welcome to saitechinfo channel, my dear student. In this session, I'll be explaining about optical activity. Optical activity means how the light behaves. We cannot say the light behaves, but it is because of the solution through which the light is passing through. For instance, let us take some that is a sugar solution, and through which I am passing a light. So when I pass the light through the sugar solution, what happens? Some energy is absorbed by this sugar solution, and in fact the transmitted light will have a different that is intensity. There is a change in the intensity, and there will be a change in the activity also. Okay, for instance, the phenomenon of rotation of light when it is passed through an optically active solution is called optical activity. For example, let me consider the light goes in this direction, and we know this has the transverse vibration. It means that is vertically it can vibrate, and vertically it can vibrate, and vertically it can vibrate. So these are all vertical plane only. Assuming that this is the direction, let me say you have got x-axis, y-axis, z-axis. X-axis, y-axis, z-axis. So along y-axis the light is moving. It means that is the propagation of light. So it means it is vibrating in the xz plane. Are you able to understand this? So this is the vertical plane. Xz is the vertical plane. Y is the direction of propagation of light. So when it goes like this, and when it is passed through, listen to me carefully, when it is passed through a prism called a nickel prism. Okay, is a type of prism. It's known as nickel, not nickel, nickel prism. So when it is passed through that nickel prism, what happens is the complete set of vibration, probably it can be polarized in this way. Polarized means separated. So probably the vertical vibration will be going in this way, and this kind of vibration may go in this way. So it means they are plane polarized light. So these two components can be called plane polarized light. Okay, now let me consider only two components here. So one is vertical like this, another is also vertical to this perpendicular, but here it is horizontal. So in this way the vertical and the horizontal vibrations are split, and they are called plane polarized light. When such plane polarized light, and this is a light I have taken here, when this plane polarized light is passed through the optically active solution, so if it is plane polarized light means that is I have selected only one plane, for instance. So I have taken only this plane. So this kind of plane is selected, and this is passed through the optically active solution. So what happens now? There will be a twist of, that is a rotation of this plane. Instead of vertically vibrating like this, okay, there will be a rotation, and this optical rotation is called the optical activity. Do you understand this? So the phenomenon of rotation of, what is this? Plane polarized light. So the phenomenon of rotation of plane polarized light when it is passed through an optically active solution like sugar solution is called optical activity. I hope now it is pretty clear. Now it is ordinary light will be polarized, vibrating in all planes like this perpendicularly. So assuming that here it is shown the light is pointing towards you, it is coming towards you, that is coming out of the board or screen. Okay, so where in this case it is vibrating in this manner. So when it is passed through the nickel prism, probably we can select only one, and that is called the plane polarized light. So this is the plane polarized light. When this plane polarized light is passed through the optically active solution. This is the optically active solution, sample solution. What happens? So here, so this is the PP light, means plane polarized light. When it is passed through the optically active solution, there is a rotation either clockwise or anti-clockwise. Are you able to follow? If it is clockwise, that is right side, means it is known as dextro-rotatory. And if it rotated towards left, means levo, L-A-E-V-O, levo-rotatory. So dextro-rotation, levo-rotation, and based on that, the sample can have two types of isomer, and they are called D isomer and L isomer. Are you able to understand now? Right. So here I was explaining about this optical activity. So which is not, it is a property of certain compounds. Okay. And the rotation, as I already suggested, either right side, that is clockwise, and that is known as dextro-rotatory. It can be represented by plus or D. Levo rotation means anti-clockwise, that is left side. So it can be represented as L or minus. Are you able to follow? Right. Next. A carbon atom attached to 4 different atoms. What is that? The carbon atom attached to 4 different atoms can be called what? The asymmetric carbon atom. That is a carbon atom that is attached to different atoms or group of atoms. It may be A, B, D, E. All are different. So such carbon atom can be represented by asterisk mark. So when I put asterisk mark, it indicates this is the asymmetric carbon atom. So do you understand? Such asymmetric carbon atoms, they have the tendency to be optically active. They have the optical activity behavior. Okay, right. And not only that condition, but there are so many conditions. Let me explain about this first. So in this case, let me consider ethanol, CH3CH2OH, where C, that is the second carbon atom. So it is, you just check whether it is it has got any the asymmetric behavior. The C is attached to hydrogen, so this is hydrogen. So this is not optically active. Why? Because it is these two hydrogens are same, whereas CH3OH. Okay, when I replace this hydrogen with any other D, then it becomes optically active. Do you understand this? Then you can say this is optically active. This is not optically active. Why? Because there are two hydrogen, so it is not asymmetric. So this is symmetric molecule. So ethanol is a symmetric molecule. It is not optically active. Whereas this deuterated means the isotope of hydrogen. So that is replacing another hydrogen. In that case, now when you keep a mirror, it forms non-superimposable mirror images. So this is the deutero compound. So it is asymmetric and it results non-superimposable mirror images. So for a compound to be optically active, there are 3 important conditions. One is you should have asymmetric carbon atom. Okay, that is point number 1. Second point is, that is, you should have non-superimposable mirror images. Non-superimposable mirror images. This one, that is non-superimposable mirror images. Okay, and the third one is there should not be any mode of symmetry. So no mode of symmetry. So when an organic compound having a carbon atom with these 3 characteristics, no mode of symmetry. There should not be any mode of symmetry. Okay, then you can say it is optically active. Do you understand? Right. So in the case of a chiral carbon atom, as I already told, it is also called chiral carbon atom or asymmetric carbon atom. So let us consider this one C, and this is known as the chiral center. Okay, so that is marked by the asterisk. So in this case, the carbon atom is attached to different atoms, and that is why it is chiral carbon atom or asymmetric carbon atom. So it may exhibit optical activity. Why? Because there is no plane of symmetry, because it can exhibit non-superimposable mirror image, and not only that, there is no symmetry at all in any planes. Okay, so it is optically active. So likewise, we have to decide whether a compound is optically active or not. Do you understand?